take a scanner, pass on your WSDL file, and over here you can see the whole structure of the web services. Say for example, this particular services will say methods like register image, deregister image, run instance, etc. So say for example, you already bought 5 images from Amazon. What you're going to do is like make a first call, register image. So that's like the whole image which is like somewhere in the back end will get registered and come in the front end because you have already bought that. And then you say start instance, a second call. So that will start the actual instance of that particular VM, and then whatever you have loaded will be available in the public. So this is how the whole web services layer would work. So this is the first session which is talking about what is going on, what is cloud, what kind of things which you are looking at, what kind of threats or threat modeling, what kind of changes which we are looking at, and one of the most key important part of the cloud is software as services and a software service-oriented architecture or SOA. Any question on this particular session? Okay, so then we'll move to So now we'll look at the second most important part, which is a cloud and a service-oriented architecture. And this particular piece is very important from the server-side perspective. It's not that relevant from the client-side perspective. So if these kind of attacks, which we're going to see, are successfully executed, then you are compromising the server-side resources of the cloud or server-side resources of infrastructure or platform. So looking at the basic of SOA, is very well known as a web service is evolving as a next attack point, or new generation attack point, or next generation attack point in the application framework. Already there are a lot of toolkits and exploits out there for exploiting this service-oriented architecture or web services. There are too many protocols and confusion as well on this. So there is no one protocol in a web services. So that is actually making making a life of a developer very interesting. There is a race for deployment as well, and already we have seen a few attacks of attacks essentially happening on the business usage as well as on this particular business application web services. So this is a typical security framework for the application in the cloud. So for example, you have an end client, which is a web services client. This web services client may be sitting in your browser, or maybe sitting in someone else's application, or maybe sitting in someone's application's cloud or platform. Then it will going to make a call. This call is going to be in transit. It's going to send a call for HTTP post SOAP envelope. So that's where the whole HTTP post method along with XML and SOAP will come into picture. This is essentially the second layer, which is the in-transit area. So like all the security which you need for the in-transit phenomenon. Then comes the vendor controlled area where your web server, your web services engine would be sitting. Maybe say for example you are running, your web server is Apache and your vendor controlled web services engine is say Access or a Tomcat and Access. So that's where the whole shell would fit in. And then comes the user-controlled area where you are actually deploying your web services. That's where your web services binaries or web services deployment shell would sit. So this is how the whole infrastructure would take place. Mapping this infrastructure into different domains inside corporate network. So you have internet, which is a web service client, then you have a demilitarized zone or a DMZ where your web server, say IIS, Apache would be sitting. Your application server, .NET or Tomcat will be sitting, and then your web services container where Access will be sitting, which may be a part of your trusted environment. Your web services call is way in the infrastructure where you have a trusted applications or a trusted boxes will be sitting. And then your database access may be coming from Access or directly from the application server, which is essentially a part of the internal corporate network. Now, some of the technology components involved are SOAP, XML parsing with WSDL, and web services code inside, which can be in any language, maybe a Java or C# or whatever language you pick and choose, you can create that part. Now the whole technology deployment would be like, say, web services consumer make a call to XML and router and switch. Now, this is in a way, this is a unique from HTTP perspective, because when we have a HTTP protocol, it's usually point-to-point protocol, be it a 80 or a 443. If you say, for example, you establish your SSL connection, it is usually a point-to-point connection, or 80 connection is usually point-to-point connection. So, say for example, I'm sitting over here, making a connection to Google over port 80. My connection pipe is actually point-to-point. But from SOA perspective, it is not point-to-point, because SOAP has enabled feature by which you can actually define the route of how your SOAP envelope can go. So you can say like, I'm on B, and if I want to go to C, go via A or go via D. So that is where XML router and switch comes into picture. A lot of different companies have this as a load balancing mechanism as well. So they define the routes depending on. And when we are looking at a million transactions in a second for the banking application or such, these kind of things will become very important as well. Then we'll go to the binding of XML method. So all different code which you have created has the binding point. So you have a banking application running in your source code, which is written in a C#, but then you have to make a binding for the rest of the world, how they are going to access those services. These XML methods you can find on UDI or local or remote servers. So say for example, I want to identify that how many applications or how many web services are published by Amazon.com, or how many web services are part of the Amazon services scheme or something like that. So there are two ways you can identify that. One, you can go to the UEDI, or you can go directly to the Amazon service. If they have published the whole list, you can fetch from there. So that's where the binding of XML method would happen. Then the parsers and conversion would take place, and then it will get to your application server, .NET or J2E. Your application code gets executed, and based on that, you will have a file or RDBMS access. So you have a file for invoke code, and then you have a file for SOAP transaction, and then you have a protocol transactions over here. And this is another interesting part, the WSDL, which we are going to see as well, which is from the security perspective or from a security professional perspective, this is one of the most important part of the web services. So this is your typical SOA stack. What we have is a transport stack, which is HTTP, HTTPS, access stack, WSDL, SOAP, XML, RPC, REST will be sitting. Then you have a discovery stack where you will be a disco, security stack, WS security, and then you have a presentation stack, which will be XML, JSON, JS object, etc. And most of the time, the cloud applications are going to access directly from the browsers. So the browser will have its own privileged stack, which is the HX, RIA, Flash, and now Flash has to be Flash and the Silverlight, because Silverlight from the Microsoft is very much competing with the Flash. And then you have HTML, JS, ROM, etc. These are some technology are complex, some technology are pretty easy to learn. But this is how the whole SOA stack would look like. And this is where all cloud APIs are going to get called. If you look at, you take any cloud application, be it a platform-specific application, be it a service-specific application, or a software application, this is the stack which you are addressing. So, say for example, you give me a cloud application. That this is a cloud application which is for storage running. So, first thing I will do is I will go and grab their specs. I will go and grab their WSDL file. From that, I can identify what they are using, what kind of a WS security in place, whether it's running on XML or JSON, whether I can access over XML RPC or REST, or my transport layer is HTTP or HTTPS. That's what we can do when we start attacking cloud, or when we start assessing cloud. Yeah.
How do you get a WSDL file?
I'm coming to it. So this is how the scanning of cloud or scanning of SOA will start. You have two different approaches over here. One is a black box approach, where you don't have any information. It's like it starts with zero information. Where you do a footprinting and discovery, and he said like, how do I identify WSDL file? How do I identify that this particular cloud? What is the footprint of the cloud application? How I can discover the call? So that is a part of the black box testing. Then you have enumeration and profile, and then you start identifying the vulnerability detection. So that is where the black box would come into picture. And sometimes you can directly go into the white box, because like a cloud provider is your client. So they say like, okay, this is my source code, this is my platform, you have access to everything. So then you don't have to do a black box testing. You actually everything is on your fingertip and you can run it. So then by using either of these two methodology or both of these methodology or gray box, which is like merge of these two methodology, you identify the issues in the cloud apps, and then you do a secure coding, you provide a web services firewall, and then you secure your web services. Now what we have over here is a unique firewall is getting in over here, which is called SOA firewall, web services firewall, XML firewall. These firewalls are built by IBM, Intel, and some other companies who are providing these kind of firewalls. Now these firewalls are very specific with XML, because some of these firewalls which is actually not running as a software, they are running as a hardware. Because what you need is a 5 million transaction in a second. These kind of a computing power you need, and those kind of a power you can't provide at the software level. So it's like actually running in the chip. So this is where your web services firewall would sit in. And these are the risks which you are looking at for your infrastructure. For example, risk in transit would be the in-transit sniffing or spoofing. If you are using WS routing protocol, for example, what your SOAP envelope, which is going from A to C from B, if someone compromises the point B, then actually is actually looking at what communication going between A to C. Then you have a replay attack over here. Risk in web services engine, you have a buffer overflow, XML parsing attacks, spoiling schema, complex and recursive structure as payload, denial of services, as well as a large payload. So these are some of the interesting attack vectors for this web services. And then coming to the deployment shell, which is a vendor-centered area, where fault code link, this is one of the most important part of web services or a cloud apps, because the fault code, as soon as you get a fault code coming from the APIs, you start fetching some interesting information. Your attack has broken something at the back end, which has been come out as a fault code. So that is interesting for us. Permission and access issues, poor policies, customized error leakage, authentication, and certification. So these are some of the deployment shells. And finally, the user shell, where parameter tampering, WSDL probing, all kind of injection. So whatever we have seen in typical web hacking scenario are possible in your cloud scenario as well. The only thing which is changing, as we are going to see, is the mechanism, how the delivery of the payload is going to happen inside the cloud. So first stage is like footprinting and discovery. So like we know like this particular cloud exists on internet. Now we want to identify how we can access this cloud. How we can start accessing the cloud API. For example, you know like Amazon is running with the DB2 services. Now like for that, you don't have to become a part of the Amazon services. If you are an attacker, you start attacking straight away. You just don't register it. You just buy that WSDL, or you just grab that WSDL and start utilizing the attack vector. So there are two different mechanisms out there to do footprinting and discovery inside cloud. One is a primary discovery, where you crawl or spider, you do a script analysis and page scrubbing, or you do a traffic analysis. Or you can do a secondary discovery as well. So in a secondary discovery, what you are doing is you are not going to go to Amazon.com. You just go to the secondary sources. You go to, say for example, you go to the Google, you go to the Microsoft, Bing engine, or you go to their UDI. If UDI is published somewhere, some kind of API, you just go and fetch that. So SOA discovery is a crawling the application, and while your crawling engine is going on, you look for certain patterns. You say whether there is any ASMX file is there or not, whether any JWS file is there or not, because all these are actually the API files or cloud API files you are looking at. Or what you do is you do a page scrubbing, you get all the client-side code on your box and then start analyzing it. So you can start looking at all the back-end calls